In the patch window, as we can see, we have a collection here of potentially 3 columns which are our oscillators, and then we have a master section at the bottom which takes all the information from these. Each of these here are basically an identical version, in some form, of the first column. That doesn't mean to say they're necessarily interlinked. However, the point is, if you learn, for example, how A works, you instantly know how B and how C are working if you wish to use them. You don't have to use them. You can instead have just the one. It can be A or B or C. However, if you have none, and when you try and trigger the keyboard, we will see we're able to push the keyboard. However, we will have no auditory output. We turn oscillator A on, and we get some sort of audio output. Oscillator B. So you do need to have at least one of these present, otherwise you'll get no audio output. So let's take a little look at what we have. I'm going to start off with a new sound. As you can see, it automatically creates an oscillator for me with, by default, a basic sine wave. And what I'm going to do is come down to the keyboard and just trigger, for example, an A. I could use my MIDI keyboard to do the same effect, and incidentally, if you use this as a standalone, you can use your QWERTY keyboard. The keys on the bottom row, Z, X, and so forth, will represent the white keys within a range. The next row above, A, S, D, and so forth, will be the black keys where appropriate. So you'll find that the F and K keys, if I remember correctly, will not trigger any sound because they represent the spaces where there are no black notes present. And the top row, Q, W, E, R, and so forth, is then a set of octaves above the first ZXC range. And so you can use the QWERTY keyboard to trigger notes in standalone. You can use hold, and when triggering a note, we have to explicitly turn it off again to stop any audio output. As you can hear, when I click a new note, it does actually stop the first note and just sustain the secondary note. We can hear we have access to a pitch shift, as well as natural enough with the keyboard. First off, we have a keyboard which will play a note which gets higher as we travel to the right. Fairly sensible and fairly logical, and what we're used to generally. This gives me a fairly smooth sound because this is set to single and sine. As you can see here, I can choose single, double, FM, frequency modulated, ring modulation, fractalize, and sync granular, as well as just sample and granular or audio in. If I leave it on single, I can choose a sine wave, which is what we have, or a collection of waveforms here. For example, triangle, if I choose OK, gives me a different tonality than what I had with sine. Likewise, if I choose saw, I get a different sound once again. And we can go through to more complex waveforms, such as organ, through to a collection here, such as harmonics, noise, and so forth. So initially, I'm going to keep with a simple sine, because it's the easiest on the ear, and to look at is the most simple. And so I have just a sine wave. I can choose a ratio, which by default is on 1. And as we can hear, this also gets higher as we travel across. And I have 3 little diamonds here that I can change in terms of accuracy. Big steps, medium steps, or little steps. So working left to right, you kind of have access to a ballpark figure, a fairly accurate figure, and a very accurate figure. So if I wanted to hit 16.1567, as you can see, I can get close to 16, first off with the left, then with the middle column, and finally with the right column. Alternatively, if you wish, you can type one in, for example 34, and this will round this down to 32 because 34 was outside the range. As we can hear, very high. Let's drop it down back to 1 again. And this is similar to what we had under the trans. I can select note, and as we can hear, each one of these is giving me the same sound. So this is the 57th note counting across. I can choose hertz, and this gives me a frequency. So 220 gives me an A, an octave below concert A, which as we can hear is the same across the board. I can instead choose 440, and all of these give me the same tone. And so here we define essentially the source of our sound.